What are we doing? Okay, so inverse functions, we're just continuing on. Now we're looking at a couple that have exponents. So really, we're just continuing practicing. How well do you know your algebra? So remember, when we're doing inverse functions, we want to replace f of x with just y, and then we want to swap the position of x and y. So we would write this as x equals -2 y minus 1 to the third power, and then we want to solve for y. Okay. So if I'm looking at this one, I see times -2 and I see to the third power. We need to get rid of both of those. The order that you do it in doesn't make a big difference, but if we get rid of the third power first, we would have to take the cube root of x. We'd also have to take the cube root of -2, and then that seems like a little bit more work than I feel like doing. So I want to get rid of the times 2 or the times -2 first. So I can just divide both sides by -2. Nice and simple, right? So x over -2 equals, these will cancel, so that's y minus 1 to the third power. Okay. So then I wish I hadn't drawn this so close. Let me make my equal sign a little small. Because to get rid of something to the third power, the opposite of that is to take that root. So we take the cube root of it, and then that'll cancel out our exponent. But then we need to do the same thing on the other side. So we have the cube root of, x over -2. And then all of this is going to cancel out. So all we're going to be left with is y minus 1. And then our very last step, to get y by itself, we would just need to add 1 to both sides. So +1 plus 1. And that gives us y. Now let's actually put the root over. So cube root x over -2 plus 1 equals y. Okay, so we could write this as the inverse of x, so f -1. I know we don't supposed to say -1, but I need to remember that, otherwise I put the wrong thing. Equals cube root x over -2 plus 1. Okay, that's one way to write this. Since it's an odd root, I can take the third root of not -2, but of -1. So I can actually, I can take the root of that negative, so I can write this as negative the third root of x over +2 plus 1. So two different ways you can see this one written. And this only works because it's an odd root. Like if this was just a square root, this would all be imaginary, right? You'd need an I in here. So all the problems you're going to see with exponents should have odd number roots because you can do math with them. And because it's only one term here. Like if you saw a problem later on, not to give out answers, like if you saw x plus 1, even though you can take the fifth root of 1, since there are two separate terms here, you can't take the fifth root of 1 without taking the fifth root of the other. So this one you cannot simplify because there's a plus there. But as long as it's just one term, right, x divided by 2, if you can simplify that and take the root of any part of it, you can. Not that you need to. Both of these are the same answer. Either of these would be correct. Okay, so that's the new part. Then I want to do one more that we looked at yesterday just for practice. So f of x is 3 over x plus 2 plus 1. So again, we replace f of x with y, and then we swap the position of x and y. So x equals 3 over y plus 2 plus 1. And then we just get y by itself. So we start -1 to both sides. So x minus 1 equals 3 over y plus 2. And then without having to do all the work, I know since I want to get rid of this y plus 2, and I also want to get y by itself, that these two terms are going to switch places, so I can just rewrite this as y plus 2 equals 3 over x minus 1. And if that doesn't make sense, go back, watch the video from yesterday, and it'll take you through the 2 steps that get us here. This just saves us some time. All right, so I still want to get y by itself, so I do need to subtract 2 from both sides, and that gives me y equals 3 over x minus 1 minus 2. And that becomes our answer. So and again, this is one way to write it. This isn't wrong. But another way, if you want to get this all in one term, all in one fraction, we need the common denominator. So I'm going to take my second term, my negative 2, and I'm going to multiply it by x minus 1 over x minus 1. Okay? Because I can add fractions as long as they have the same denominator. So then this becomes 3 over x minus 1. And then I need to distribute this 2 out to our numerator. So negative 2 times x is negative, actually let's do plus here. So plus negative 2x. Negative 2 times negative 1 is plus 2 over x minus 1. So now since both my fractions have x minus 1, I can combine whatever I can. So 3 plus 2 is 5 minus 2x over, and then when you're adding fractions, the denominator doesn't change. Remember, 1/8 plus 1/8 is not 2/16, it is 2 over 8, right? The denominator stays the same throughout. So this answer here is equivalent to that answer there. So depending on what the answer choices look like, if you do the work and you get this answer, but you don't see it, then you might have to go through this extra step to simplify it down to one fraction. Okay? But really, we're just continuing on practicing how to write inverse functions. So good luck. Let me know if you have any questions. Bye.